Hello ladies and gentlemen, my name is Juma Mlawa, and I'm part of MOGO. MOGO is our organization for the Senior Design Project. The project that we're doing is Reservoir Simulation and Optimization, a case study. The other team members are Kojo Orgle, Henrietta Mofoke, Maryssa Offlee, and our project manager, Yoel Gebrai. Our organization recently acquired field data from the North American Prospect Expo NAPE. The NAPE conference, which is held frequently in Houston, Texas, serves the primary purpose of creating a platform for buying, selling, and trading oil and gas prospects and their data. The data we acquired gives plausible odds that this particular field is profitable. With this data, we intend to use reservoir simulation software, in our case CMG, to come up with the most favorable development plan. This prospective field was abandoned, and despite the current market volatility, our team believes we can make this field commercially viable again. Our analysis intends to include typical industry costs such as drilling, production, development, and transportation, just to name a few. Additionally, our team of reservoir engineers will determine the oil and gas recovery of our prospects, plus any measures that would allow us to maximize the return on our stakeholders' investment down the line. As with any industry, the oil and gas industry is constantly evolving. As such, to ensure that our business operates smoothly and efficiently, we have some clearly defined business objectives. They are to produce oil and gas from fields in a profitable, responsible, and environmentally clean manner, to develop and pursue additional exploration and production in areas which are of moderate risk and perceived to be cost-effective, to complete all planned research within scheduled time and sanctioned cost, and lastly, to earn a reasonable rate of return.
For us to attain our goals for this project as a team, we would have to complete milestones at respective target dates to ensure smooth workflow. Also, we will have to meet regularly as a team to enhance team liaison, communicating any concerns to team members and advisors in a timely manner. And most importantly, we would have to increase our computational efforts so as to learn how to use the software and use it correctly to obtain realistic results and maximize returns. Reservoir simulation requires field data, which we will get from North American Prospect Expo. Also, reservoir simulation involves using computer models to predict the flow of fluids through porous media. In our case, we will be using the CMG software to do this reservoir simulations.
In performing our reservoir simulation, there would be some constraints that our team would come across. Some of these constraints can be mitigated, while some constraints are on a much larger scale and cannot easily be altered. Some of the constraints we must consider are the complexity of the CMG software and the small time frame that members have to become familiar with the program, and the instability of current market conditions and the uncertainty that comes with it. Successfully completing the project would require the use of several calculations and techniques. The calculations and techniques used would have to be initially based on logical assumptions made by our team at MOGO Exploration and Production. These initial assumptions are: our reservoir is composed of a non-volatile oil and a volatile gas soluble in the oil phase. The reservoir is homogeneous. There are proven oil reserves in the field. There are several more assumptions that will be identified and included as our project progresses. In terms of the preliminary scope of our project, the project will include the use of commercial reservoir simulation software to perform reservoir simulation based on data provided. The results of the simulation will aid us in determining the oil recovery of the prospective field. In order for the project to run efficiently and be successful, it would constitute completing the reservoir simulation training and becoming more familiar with the software, communicating with team members and advisors on a regular basis to improve the quality of the project, and continuously analyzing the data to ensure that we are on schedule to complete our project in an efficient manner.
The reservoir engineering team at MOGO E&P will utilize the LSU Petroleum Engineering Computational Laboratory on the third floor of Patrick F. Taylor Hall for the purpose of executing our reservoir simulation and optimization study. We are not anticipating having any problems with access to CMG, but there have been instances where undergraduates have not had access to the software on the computers there. The construction currently going on in the building also increases the likelihood of this happening. Lack of access to the software necessary for our study is a high-level risk and one that will be a major setback for our project if it were to occur. Additionally, risk and uncertainty are inherent in reservoir simulation. Therefore, the possibility of losing money on an investment or in producing unrealistic results is always present. We are also using a data set that we did not acquire ourselves, and as a result, we must analyze the data, verify its accuracy, and ensure that our results are of a realistic scenario and not the result of a misinterpretation. However, through the use of effective communication and responsible time management, we believe that the probability of any of these risks is very low, and that we have what it takes to successfully complete this project and learning experience. Upon completion of the project, stakeholders and project sponsors would be able to estimate the ultimate oil recovery from the well, the net cost required for completion or abandonment, and the net profits that could be attained. From this information, stakeholders and project sponsors will be able to make a logical decision as to whether it is economically feasible to drill at the prospective field or abandon the well and seek other prospects.
The successful completion of this project will result in the quantification of cumulative oil and gas recovery. The production scenario where the net present value of our project is optimized is also going to be identified. Some of our project milestones include beginning the execution phase of our project by January 1st. By January 21st, we want to have the data inputted into the simulator. By January 26th, we plan on analyzing some of the simulation results. By March 1st, we plan on completing the history matching. And by April 1st, we plan on having the optimization portion of our study completed. By April 20th, we should be beginning constructing our presentation, and by April 30th we plan on having our project complete. We are going to be utilizing the Petroleum Engineering Computer Lab on the third floor of Patrick F. Taylor to have access to CMG and MATLAB at no cost. As a result, the budget for our project is $0. My name is Yoel Gebrai, and I have been assigned as a project manager. Some of my responsibilities include ensuring that the reservoir engineers on our staff have access to the tools and resources they need to complete this study. I also have a hand in scheduling of the milestones and declaring the timeline by which this project will be completed. I'm also arranging meetings with faculty collaborators and potential faculty collaborators. We have begun holding discussions with potential faculty collaborators, and things are looking promising. We have yet to identify a faculty collaborator, and as a result, a faculty advisor has yet to approve this study. However, this project is still in its infancy, and we are going to continue developing ideas and holding talks with faculty.